In the middle of World War II, as supply lines buckled under enemy fire and fuel convoys vanished in smoke, a small team of engineers managed to power entire communication posts and field stations without a drop of gasoline. No diesel, no coal, not even generator fuel. Their secret? A self-sustaining field battery that ran entirely without combustion. It was compact, silent, and crucially invisible to enemy reconnaissance. And while it never made headlines like radar or the atomic bomb, this forgotten invention quietly changed how soldiers powered radios, lamps, and instruments at the front lines. Today, most people have never heard of it, but the so-called fuel-less field battery represents one of the most ingenious pieces of wartime engineering ever devised. A device that turned chemistry into survival when every drop of fuel was life or death. By 1941, mobile warfare had stretched the limits of logistics. Armoured divisions and mobile command posts required electricity for field radios, encryption equipment, and signal lamps. Yet fuel shortages often left generators idle. In North Africa and the Pacific, supply routes were too dangerous, and in Eastern Europe the bitter cold made many generator engines seize up. Allied field engineers began experimenting with portable power sources that didn't rely on volatile fuel or complex moving parts. What they came up with was an electrochemical field battery that used readily available materials: water, air, and metal. Known in some documents as the Type E self-activating battery, it relied on a principle as old as science itself: galvanic reaction. This was no dry cell or lead-acid unit. Instead, it used plates of magnesium and copper submerged in an electrolyte made from salt water. When activated, it could produce a steady electrical current, strong enough to power field radios, signalling gear, and even low-wattage heating coils. Unlike gasoline generators, it didn't make noise, didn't emit smoke, and required no spare parts. Soldiers could carry multiple units into the field, activate them as needed, and power their gear without worrying about detection. The brilliance of the design lay in its simplicity. The engineers based the system on the galvanic reaction between dissimilar metals. Magnesium, being a highly reactive metal, served as the anode, while copper or carbon acted as the cathode. When the two were connected by an electrolyte, typically a saline solution created by mixing salt with water, a chemical reaction began, producing a flow of electrons. Each unit was capable of delivering between 1.5 and 2 volts per cell. Several cells could be linked in series to provide higher voltage for larger devices. The electrolyte didn't need to be specialized. It could be seawater, stream water, or even rain mixed with salt from a ration pack. Once activated, the battery would continue to produce electricity until the magnesium plate was consumed, which could take anywhere from 24 hours to several days, depending on load. This was revolutionary at the time. The US Navy and the British Royal Signals Corps both tested variations for emergency communication sets. One version, developed under the Bureau of Ships, was a flat, rectangular box sealed in wax. When needed, soldiers broke the seal, poured in seawater, and within seconds had a functioning power source. For radio operators, this was a lifeline. Portable sets like the SCR 536 handy-talkie or the British No. 18 set demanded a steady voltage that traditional wet cell batteries couldn't maintain in harsh environments. The fuel-less field battery provided that stability without mechanical failure. Soldiers stationed near the coast had an unlimited supply of electrolyte, seawater, and could carry spare magnesium plates that fit neatly into the battery compartment. In the Pacific, US Marines often relied on these for short-range communications when generators failed or were too risky to run at night. In Arctic campaigns, the same units worked flawlessly in sub-zero temperatures where traditional lead-acid batteries froze solid. Even more fascinating, survival manuals from the late war years included simple instructions for building improvised versions using scrap metal and saltwater, a trick that survivalists can still apply today. To replicate this in a modern survival setting, you'd need strips of magnesium, which you can find at camping stores as fire starters, copper wire, and a container of salt water. Place the metals in the water without letting them touch, directly connect them with a wire, and you'll generate a usable current. While it won't power a car, it can easily charge a small radio or LED light in an emergency. That's living proof that this forgotten wartime invention still has relevance far beyond the battlefield. The legacy of the World War II fuel-less field battery didn't end when the war did. The same principles went on to inspire developments in seawater-activated lifeboat batteries, early hydrogen fuel cells, and even the modern magnesium air batteries now being tested for electric vehicles. The concept, deriving energy from a metal-air reaction without combustion, was decades ahead of its time. In 1944, the Allied Materials Laboratory in London conducted trials on a variant that used aluminum instead of magnesium. It ran longer but produced slightly less power. After the war, engineers refined these concepts for emergency beacons and naval life rafts. Every time you see a pull-to-activate rescue battery that powers automatically when it touches seawater, you're seeing a direct descendant of this World War II innovation. The key takeaway for both history buffs and survival enthusiasts is simple. The best technologies often emerge from scarcity. These batteries were born not from abundance, but from the need to survive when fuel was gone and silence was vital. The forgotten field battery teaches one of the most valuable lessons from wartime engineering. True innovation doesn't always require complex machines. Sometimes it's about understanding natural principles and using what's at hand. In the 1940s, soldiers used seawater and scrap metal. Today, a survivalist could do the same with modern equivalents. If you ever find yourself off-grid, stranded, or experimenting with old technologies, this knowledge can become practical. A magnesium air battery setup can be built from camping tools and a little know-how. It's not about nostalgia. It's about reclaiming self-reliance through understanding forgotten science. The fuel-less field battery stands as a silent symbol of wartime ingenuity, a power source that asks for no fuel, no flame, only understanding and creativity. For those who appreciate the hidden engineering victories that shaped history, this story reminds us that progress isn't always loud or flashy. Sometimes it hums quietly in a saltwater box on a forgotten battlefield. If you enjoyed uncovering this lost piece of World War II innovation, don't forget to subscribe to In the Beginning and share this video with other history enthusiasts and survival-minded viewers. There are countless more inventions like this waiting to be rediscovered, and together we'll keep their stories alive, one forgotten device at a time.